Hey guys, what's going on? We're back again. We're going to be introducing myself, Alessandro Faretta.
And I'm Daniel Bishay.
And we're going to present to you today Jerry Coyne's book, Why Evolution is True. We're going to be presenting Chapter 4, The Geography of Life. And we have a cool quote down here. We're going to get it started off right by Jerry Coyne himself, saying evolution was necessary to explain not just the origins and forms of plants and animals, but also their distributions across the globe.
So, we're going to recap real quick. In case you missed our last video, I hope you didn't, but in case you did, we'll go through it real quick. So, we know evolution is true. Hard fact, we talked about this in Chapter 2. And we've seen the fossil record. It's been shown to us and it's been proven to us that simpler life beings once roamed this planet many, many, many years ago. So from there, we've seen that we and other complex organisms have evolved from these simpler beings over this period of time. So, we know how we've come to be, but why are we here today? Specifically, in this location, where we are. Why are species in their exact location where they are today? We're going to find out today.
So we're going to begin here with the distribution of life, and this is a grand scope of things that we're going to be breaking down in this presentation today. So evolution is great. Not only does it help us learn where we came from, but it also tells us why things are at the exact location they're at today. Life is distributed all over the planet, and many different species that look like each other, but are in fact different, are on 2 different continents. And we want to ask ourselves, how is this all possible?
Enter biogeography. So, I know biogeography sounds scary, but I'm going to break it down for you. Biogeography essentially is the branch of biology that deals with the geographic distribution of plants and animals. Biogeography helps us to see the distribution of living organisms all around our planet and how they came to be there. Down at the bottom, you'll see this really cool image of all the continents as they are today, with all of the species diversified and laid out through all the continents. And this map was actually produced by Alfred Russel Wallace, who was very prominent in this field and really helped to visualize the different species and how they spread out over the continents.
Why is biogeography so important to us? Knowing where these organisms are today and where their ancestors were back then is vital to us. This is going to help us come up with different theories and further prove some of our thoughts that are being considered here. Biogeography helps us predict past environments and make predictions as to where descendants of these species live today.
So let's just kind of go over a little history of biogeography. Back in the 18th century, many viewed the world through the lens of religion. Everything was kind of viewed with the whole creationism theory, and no one really got the concept of the fact that evolution was really a thing. So, we do have Carl Linnaeus, though, who started discovering organisms as he explored many uncharted and undiscovered territories, and you'll see him down there at the bottom. And he noticed that when many similar species, he realized that species were not as never-ending as he had once believed. There's a little cool quote down there by Linnaeus, and he says, "In natural sciences, the basics of truth must be confirmed by observations."
So more on the history of biogeography here. We next see Charles Lyell helped further develop the concept of biogeography. He developed the theory of uniformitarianism. This theory stated that the planet was created from numerous events and locations. He said that the way things are today were likely how they were in the past. This was a huge thing. This set the stage for us to determine how things, organisms, got to where they are today.
And of course, no history would be complete without Charles Darwin. He helped seal the deal on the idea of biogeography. He said in his famous book, The Origin of Species, When on board HMS Beagle, as a naturalist, I was much struck with certain facts in the distribution of inhabitants of South America, and in the geological relations by the present to the past inhabitants of that continent. These facts seem to me to throw some light on the origin of species. It was now clear biogeographic evidence was irrefutable. The idea was so irrefutable that creationists didn't even try to argue it. They just simply pretended it didn't exist. And then you got the cool guy down there, Charles Darwin.
All right, so we're going to talk about the distribution of life here. Going to get started on that. Thanks to the development of the ideas of continental drift, we now have the answer that Darwin did not have back then. Continental drift was the gradual movement of the continents across the Earth's surface over time. We went from Pangea, which was pretty much like a supercontinent. All of our continents today were all meshed together, to the distribution of our continents as we know them today. And the continents keep moving today. And it's said in a 2007 New Science journal that Pangea Ultima would happen and would come again in 250 million years from now. And Pangea Ultima is pretty much the continents going back to the original Pangea form. This is only a theory, however, and it has not been proved, as it is impossible to see that far into the future.
Although that does sound pretty cool. Next, we'll kind of go over the idea of convergent evolution and how it kind of ties into this whole concept of where things are today. So convergent evolution helps us to explain why different types of organisms, particularly animals, have the similar forms in different places. So species that live in similar habitats will experience similar selection, so they will evolve and adapt in similar ways and behave and look alike and still be completely unrelated. Down there you'll see some examples that we have between placentals and marsupials. You have the flying squirrel, you have the anteater, and the different types of mice. All of those are just kind of an example to show you that they're completely unrelated, but they look so similar to the point where you think they're the same thing. But they've evolved and adapted in the exact same ways, but they've done so independently.
So convergent evolution. The theory of convergent evolution is extremely helpful as it combines the ideas of common ancestry, speciation, and natural selection to answer the ultimate question we're trying to answer here. How did things get to where they are today? Combined, convergent evolution explains how species are diversified and distributed across various continents. It solves the issue on how animals look so similar yet are on opposite sides of the planet.
Descendants came from ancestors. I know I don't really have to say it, but I'm saying it anyways. It's pretty obvious by now that descendants came from ancestors. Solid fact. So, assuming evolution did happen, and it did, species living in one area should be descendants of other species that were once living in that same area. What does that mean? That means if we dig up fossils in that area, the fossils residing closest to the top layer should resemble the species that are currently living in that same exact area.
And we're going to have a few last words here on biogeography. Biogeography has been shown to be the reason behind the spread of species all over the continent. It simply answers the idea of how life came to be so spread out and diverse across all continents and islands. And again, we see this little drawing down here, and the fossil evidence, you can't deny it. It shows what is closest living there today on the top layer, like Daniel said in the first slide. And we see that biogeography is actually true and real, and we're able to observe this.
And that about wraps it up for the geography of life. We have this little funny cartoon here that you've got one penguin saying, "It's cold here now, I know, but according to my calculations, Antarctica will be back at the equator in another 50 million years. And then you have the other penguin, who looks pretty cynical and cold, saying, "We should have listened to the lemurs and joined them on Madagascar." Well, thank you guys so much. I hope you enjoyed this presentation. Again, this has been Daniel Bishay.
This is Alessandro Faretta, and just thank you guys again.
Take care.